Hi, my name's Joe Graney. I'm a licensed hearing instrument specialist in Massachusetts, and I just wanted to make a brief video today about noise-induced hearing loss, something I see all the time in the office. Um, I'll use some books from my library to kind of go over it and show you some figures that will hopefully help you visualize it more. So these images here show the canal resonances, our ear canal resonances, and the effects of the outer ear on sound pressure level. So we see that between 2 and 6 kilohertz, there's a significant boost in sound pressure level. These images show the same thing, where there's that boost between 2 and 6 kilohertz. So really, that's nature's blessing. Nature gave us those ears to look that way and to be created that way, so that we can have a boost between 2 and 6K, where a lot of clarity in speech comes into play. But when we look at noise, noise has a broad band, is broad across the frequency spectrum, and has energy that's across the frequency spectrum, across the bandwidth. So what happens is, with noise, we have that blessing and a curse. Because what this is you can see the damage done. This is a bilateral mild to moderate high frequency loss due to noise exposure. And you can literally see that the blessing of that boost in sound pressure level is also a curse, because now we have noise-induced hearing loss. And these lines indicate higher severity. This image here displays the same thing, where you have this noise notch, especially at 4 kilohertz, and then recovery at 6 and 8 kilohertz. You can see on this image the recovery that occurs. What often accompanies noise-induced hearing loss is tinnitus. This is, a permanent threshold shift, where we have, permanent sensory loss. I drew this in to indicate that above 6 decibels hearing level, the damage would be done to the inner hair cells. The inner hair cells are the afferent fibers that send information from the cochlea to the brain. So if it's less than 60 dB, you have damage to outer hair cells, and if it's greater, the damage is really done to the inner hair cells as well. When we look at the cochlea, this is a healthy cochlea with hair cells all along the basilar membrane. And this is a cochlea that has noise-induced hearing loss. The cochlea is tonotopically arranged from base to apex. What this means is that it's place frequency arranged. So you have high frequencies represented at the base and low frequencies represented at the apex. This is similar to what I like to say is a piano. If you've ever looked at the strings of a piano or the reeds of a harmonica, you can see that the low frequencies are represented at the apex, and at the base there's high frequencies. So this is the damage is done at the basal turn of the cochlea to those high frequencies. So what can we do to prevent noise-induced hearing loss? We can wear hearing protection, and certainly hearing aids can help bring back these high-frequency sounds, which really help with speech clarity. And by bringing back those high-frequency sounds, we get those high-frequency consonants in speech that distinguish one word from another. So hearing aids help if you have noise-induced hearing loss, and certainly wear noise protection. I remember when I was in high school, I went to a Who concert and had a temporary threshold shift, which, I had hearing loss overnight, but it had recovered the next day. But if you have noise exposure all the time, you're going to have a permanent threshold shift. So wear hearing aids if you have the problem, and wear hearing protection if you don't. And even if you do wear them. So, all right, hope this gives you a general idea about noise-induced hearing loss. My name's Joe Graney, and thanks again.